Chapter 6, Section 5, Properties of Logarithms. We've been dealing with exponential form and logarithmic form. We just learned that those are inverses of each other. A couple of sections ago, we looked at the graphs in 6.4. If you did 6.4, mostly we're using Desmos to help us graph and know what's happening there. But we're going to look at the direct properties. Like exponents have properties where if it's the same base multiplying, you add the exponents, same base dividing, you subtract the exponents, and so on. Logarithms also have properties, and so we can see three here. There's a product property. In a logarithm of a certain base, when you're multiplying two numbers together in that log, you can separate it into log of the same base of one plus log of the same base of the other. Okay? Just like whenever we could take b to the x times b to the y, and it's b to the x plus y. They're multiplying together, so we add them. Same deal. Okay. Quotient property, similar. It's going to be a subtraction. The power property is an interesting one. If it's log base b of some number m to the n can actually come out in front. But it is also the case that you can pull the n back inside if you need to. Either one works. Okay. So we're going to use those properties to solve some problems. Starting out, they give you this. Use log base 2 of 3 is approximately 1.585, and log base 2 of 7 is approximately 2.807 to evaluate each log. So what we're going to do is we're going to break these into either a log base 2 of 3 or a log base 2 of 7 or some combination of more than one of those or one of each of those. This is like if we didn't have a calculator and they told us to solve this problem. So let's look at log base 2 of 3/7. We don't have one for log base 2 of 3/7, but we do have one of 3 and of 7. So if we could separate them, we'd be good. And since they're in division, what we can do is we can turn that into log base 2 of 3 minus log base 2 of 7. Now we can plug in our substitutions. 1.585 minus 2.807. And 1.585 minus 2.807. And we can do that. Negative 1.222. Okay. And we can do it long-handed if we needed to, but I got the calculator, so might as well use it. Now, log base 2 of 21, there's not a 3 or a 7 there. But remember, 21 is 3 times 7. So we can turn that into log base 2 of 3 plus log base 2 of 7. So we got 1.585 plus 2.807. Do this one long-handed. 5 and 7 is 12. 8 and 1 is 9. 5 and 8 is 13. 1, 2, 3, 4. So 4.392. Log base 2 of 49. We can do this one a couple of ways. We could say 49 is 7 times 7, which would make it log base 2 of 7 plus log base 2 of 7. But we could also say that it's log base 2 of 7 squared. And we can pull that 2 out in front and say it's 2 times log base 2 of 7. So it's 2 times 2.807. And then we just have to multiply it by 2 or add it to itself. That's what multiply by 2 is. So 2 times 7 is 14. 2 times 0 is 0. Plus 1 is 1. 2 times 8 is 16. 2 times 2 is 4. 5. 5.614. Here's a couple for you. They've changed the numbers up. Log base 6 of 5. Log base 6 of 8. Plug them in. Try them. Take a minute. Come back. See what you get. All right. Let's look at number 1. They're in division, so I can say log base 6 of 5 minus log base 6 of 8. So I've got 0.898 minus 1.161. Let's divide them. That goes 8. I don't know why I did that. That's dumb. 8 minus 1 is 7. Don't need those. 9 minus 6 is 3. 8 minus 1 is 7. And 0 minus 1 is negative 1. There you go. Log base 6 of 40, well, that's 5 times 8. So we got log base 6 of 5 plus log base 6 of 8. So 0.898 and 1.161. 8 plus 1 is 9. 15, 8, 9, 10. Here we go, 2.659. That's 8 squared. So 2 times log base 6 of 8. So 2 times 1.161. 2, 12, 2, 3, 2, 3, 2.322. Log base 6 of 125, that's 5 to the third. So 3 times log base 6 of 5. So 3 times 0.898. 4, 2, 27, 28, 29, 24, 25, 26. And 2.694. Just like that. Now our calculator can handle that, especially Desmos. Desmos goes easy. We could have just put in functions, log with a different base, put in our 6, and then in here we could have done 5 divided by 8. Now, they got a different answer than I got. So let's double check and make sure what we did was good. 0.898, 161, 8 minus 1 is 7. 9 minus 6 is 3. 8 minus 1 is 7. 0 doesn't. So maybe that's where I went wrong. There's no borrow. So what's the difference? But it's going to be negative. Let's see, 1.161898. Let's do it this way. Borrow from here, 11 is 3. Borrow from here, 15 is 6. 10 is a 2. Aha. So we need the difference, but negative. It's interesting. So not that. All right. Those add, I'm sure. Let's double check that one. Let's see, 6 of 40. 2.059. Yeah, that's because we're rounded. Oh, was that an O? Let's see. 9, 15. Yeah, it was an O, not a 6. There we go. Good. And we could do 64. 2. Well, that's because of the way they rounded their... remember, they approximated first. So you can see how if you do it actual versus using an approximate and an approximate to make another approximate, you get off a little bit. And then let's do our last one, 125. 2.694. Should be 5, actually, if we rounded to that third spot. But we're pretty good. And that's what they're asking for. Just seeing a way to break these apart, okay? We're getting into very puzzle piecey type math when we get into exponents and logs and then rational functions. You got to see the forest through the trees, that kind of thing, okay? So expanding. So all we have to do here is blow this thing apart as far as we can. Now be careful because we do have an ln. It's a natural log, but they have the same properties. Remember, ln is just log with an e base. Same thing, okay? So we can break these apart. So starting out, we can turn this into ln of 5x to the 7th minus ln of y. That division piece, that biggest piece that goes first. Now everything that's in the top can separate. That's a multiply. So we got ln of 5 plus ln of x to the 7th. That's a bad ln. ln of x to the 7th minus ln of y. And then we can bring that 7 out in front. So we got ln of 5 plus 7 ln of x minus ln of y. And that's as expanded as we can get. It's not asking us to solve anything. There's not an equal sign in there anywhere. They just want us to use the property to break it apart as far as we can. Now we're going to reverse that. Okay? So we start with exponential first, and then we look at add, and then we look at subtract. So what I'm going to condense first is the 3 is going to come back here on the 2. So we got log of 9 plus log of 2 to the third minus log of 3. Okay. Now I would actually do 2 to the third because it's not that bad. It's not a variable. So I would say that's probably log of 9 plus log of 8 minus log of 3. Now we can do the add part first, so we can say log of 9 times 8 minus log of 3. And then we can pull that and go log of 9 times 8, or 72 if you want to call it that, divided by log of 3. Now that 3 is going to go into that 9. Okay. Goes in once 3 times, so we get log of 24. You could also say log of 72 divided by log of 3. The 3 goes into the 72. Okay, all at that time. Oh, and actually it should have all been one big log right back here. Let's do that. Write it properly. When we bring that 3 under, it's just log of 9 times 8 over 3. Scratch, scratch, log of 24. Putting it all together. Okay. All right, so you got a couple expanders and a couple of condensers. Give it a pause, try them, come back, see how they go. All right, number 5. It's times, so I'm going to break that part apart first. The exponent of 4 is not on both, so I can't bring it out in front yet. I have to separate them. So log base 6 of 3 plus log base 6 of x to the 4th, and then we can bring it out front. So log base 6 of 3 plus 4 times log base 6 of x. Let's look at number 6. This is natural log this time. That's okay. We're in divide, so ln 5 minus ln of 12x, and that's a multiply. So ln of 5 minus ln of 12 plus ln of x. And when you do these left to right in order, this minus that comes first, everything that follows is what is being divided whenever you put it back together. Okay? Everything that follows, not just the piece that follows, because the plus sticks those guys together. And you don't want that x to end up in top. You're subtracting that whole thing. Remember back here it was a whole thing. So there it's a whole thing. Okay, left to right in order. Now let's look at 7 and 8. Squeezing them together. Condense. We've got a minus, so it becomes log. Minus means a division sign. X on top, 9 on bottom. That was nice. Here, we got to go in order from left to right. Now we've got a multiplier in front that we can bring back first. So ln of 4 plus ln of 3 to the third minus ln of 12. They're not grouped together, so the 12 is the thing that goes on the bottom. Okay, the 12 is the thing that goes on the bottom. So we got ln of 4 plus ln, that's an h, plus ln of 27 minus ln 12. So we got ln of 4 times 27 minus ln of 12. And then we got ln of 4 times 27 over 12. And the reason I left it that way is because 4 is 4 times 3 and 27 is 3 times 9. And if we scratch the 4's top and bottom, we scratch the 3's top and bottom, all we have left is ln of 9. Okay? Easier than making the numbers bigger and trying to reduce them. Change of base. Now this is a thing you need in case you don't have a calculator that can change the base for you. You may need to make things the same base so that you can combine them in ways or eliminate them in ways. So logarithms with any base other than 10 or e can be written in terms of common or natural logarithms using the change of base formula. This allows you to evaluate any logarithm using a calculator. So they're using this just so you can plug it into a calculator. our calculators can do the change of base formula for us. But this is an important deal. If you have a log of a certain base of a certain number, you can turn it into a division of a log of a new base. See how this is new? And the original number and the base goes on the bottom. Excuse me. So you can change any base into any base that you want. If you've got log base 6 of 4 and you want it to be in log base 12, you go log base 12 of 4 on top and log base 12 of 6 on bottom. Now it's in log base 12. And you can change the top into another, and you can change the top into another. Most of the time, people change it into regular old common log so that you can type it in a calculator, because even your basic scientific calculators have at least the regular log button, even though they can't do change of base. Okay? You take your main calculator on your phone, when you turn your phone sideways to scientific, it's got a log button. It doesn't have change of base like Desmos or the TI-84 does, but it does have a log button. So you just change it to log base 10, and then you can do your calculations. So evaluate log base 3 of 8 using common logs. So they want us to take log base 3 of 8 and turn it into log base 10, or the common log. The 8 goes on top, the 3 goes on bottom. And then we work on that. So funcs, all we need is a log button, base 8, and divide, and log of 3. And so it's about 1.893 if they're looking for a rounded decimal. And they are. Okay? Just like that. Okay? Evaluate this using natural logs. You can do it with a natural log instead of a common log. All you do is take log base 6 of 24, and we're going to turn it into log base E. So instead of log base 10, like we did on the last one, let's see, I'll show you, I'll do a different color. Remember, we made little 10s right here. That's the common log. So now we're going to do logs with a base of E, but we don't do log, we do ln. Okay, so we got ln top, ln bottom. The top's 24, the bottom is 6. And then we just approximate it. Functions, ln 24, close divide, ln 6, 1.774. Just like that. Now, pesky old tricky old word problem. For a sound with intensity I in watts per square meter, the loudness L of I of the sound in decibels is given by this function. So loudness is given by, in terms of intensity, 10 times the log I over I sub 0. Where I sub 0 is the intensity of a barely audible sound, about 10 to the negative 12 watts per square meter. An artist in a recording studio turns up the volume of a track so that the intensity of the sound doubles. By how many decibels does the loudness increase? So we need to know a difference. What was it originally, and what is it now? Okay. Well, originally, you use this. Technically, this part of this. If we want to double, okay, the sound, we want to double the sound, double the intensity, right? The intensity of the sound doubles. Intensity is I. So that would be 10 times the log of 2I over I sub 0. That would be doubles. And then original would be 10 log of I over I-O. We need to find the difference. By how much does it increase? By how many increase? So what's the difference in sound from regular to doubled? That's what we want to know. How much does it increase? What is the factor? So because they're both times a 10, we can pull the 10 out. Make it log of 2I over I sub O minus log of I over I sub O. And because these are multiplying, we can say 10 times log of 2 plus log of I over I sub 0 minus log of I over I sub 0. And these are the same, so they cancel. So we're left with 10 log of 2. The loudness increases by 10 times the log of 2 decibels, or about 3 decibels. See, we could do 2 to the 10th, but I'd rather just multiply 10 times the log of 2. So about, let's see, what is 10 times the log 2? 3.010. Okay. That one's a weird one. They just want you to simplify that out. They want you to break it apart as much as they can and then take out as much extra stuff as possible. And that's what we've done by reducing it to 10 log base 2. Okay. My main focus is 9, 10, 11, and 12. But you could try 13 if you wanted to. All I do is change it so that the intensity triples, and then by how many does it increase? What's the difference? Okay, so give it a pause, give it a try, come back, let's see what you did. All right, here we go. 9. Use the change of base to evaluate the log. So that's log over log, 8 over 5. Now, if we do log of 8 divided by log of 5, we get about 1.292. Now, just to be curious, what if we did our change base one and we did log base 5 of 8? Gives us the exact same number. Doesn't matter which way you do it, because all the calculator is doing is changing the base for you. Let's look at number 10. Log of 14 over log of 8. Log 14 divided by log 8. And we're at about 1.269. 11. Log of 9 over log of 26. Uh, 0.674. Number 12. Log of 12 over log of 30. Okay. Under, actually, log 30 over log of 12. .369. And there they all go. Now, if we look at the word problem, it's very similar to the one that we just did. So if we go back over here and look, this time it was doubles, so we put in a 2 next to the intensity. This one they want triples. So for 13, it's going to be 10 times the log of 3i over I sub 0 minus 10 log I over I sub 0. Pull out the 10. Log 3i over I sub 0 minus log I over I sub 0. Those are multiplying. Pull out the 3. 10 times the log of 3 plus log of I over I sub 0 minus log of I over I sub 0. Those eliminate. So we got 10 times the log of 3, which is about, oops, wrong one, 3, 4.77, 4.77, what was the other one? 771. They've been doing it to 3.